record? Can everybody hear me okay? Probably clear because I have the headphones on, right? That's so you don't hear everything else that's
Yes.
going on. Okay, so today is start of chapter 9, which is hypothesis testing. Now, remember when we did confidence intervals where we had like 3 days of precursor knowledge or things that built us up to actually being able to do the confidence intervals? We're doing the same sort of thing with hypothesis testing. We're going to work on it today, tomorrow, and Wednesday. And then Thursday, we're going to do a full example. To look ahead at the rest of the semester, we have a quiz this Thursday. Okay. Next week is Thanksgiving. So we have class Monday, Tuesday, then we don't have it the rest of the week. Then the following week, we'll have a quiz on Thursday. And then the following week after that is our last week of the class, and we'll have the last test. And we also have one more project in there. So for grades, you have 2 quizzes, 1 test, 1 project, and 12 homeworks, and you're done with statistics. Okay, that should feel good. You guys are almost at the end. You're at the finishing lines of it. Okay, so 3.5 weeks and we're out. So we have chapter 9, chapter 10, and chapter 11 are the last chapters that we're going over. Kanisha's like, I'm really done. I'm ready to be done, right? I've really enjoyed having you guys as a class. So, so let's start into today. Now, the first part of today is writing down definitions. I'm not going to talk about them as much while you're writing down the definitions as I am going to after you've written them down. Please do not paraphrase the definitions. Write them exactly how I have them, and I promise you it's going to be beneficial to you. Okay, and once you've written them down and we do some examples at the end, and when you look at the homework, it'll make sense why I asked you to write them down exactly how I have them written down. So let's look at that. This PowerPoint is online, so you can follow along and copy it from there if you would like to. I am not going to write them down because I already did on the PowerPoint. So here's the first set of definitions. As you are writing stuff down, I might highlight just to, so p-value. The p-value, this is a value that's between 0 and 1. It can be equal to 0, it could be equal to 1. Most of the time you won't see that, which we compare to the significance level. This is found through the process of hypothesis testing. And it is the probability associated with the test statistic. All of that wording is important. The significance level is a set value that allows us to make conclusions about whether our sample parameter is, I'm going to change that to different. Different enough than the claimed population parameter. And the claimed parameter is the known average or proportion, what we compare to for the hypothesis. I really don't like that pink, that yellow, it's off-putting. Is that better? It's like visual things. You're like, oh, that doesn't make sense. That doesn't look good. Let's try blue. Is that better? So please write these down exactly how I have them written down, or reference back to these slides and the exact wording. And as a side note, if you haven't seen it, they're talking about they're doing flu clinics and vaccine clinics on campus this week and next week, I think. So apparently H102A tomorrow, Wednesday, they're doing them, and then December 7th and 8th. And you don't need an appointment, you can just walk in. So, anybody need more time to write down? Okay,
Give me
I
like
see the
30
thing.
seconds.
Yeah. And go. No, I'm just joking. Okay. Here's some more definitions. So a claim is a statement about the population parameter. Now it's going to either have population mean, or it's going to have population proportion that you're using to compare. Okay, those are the population parameters. Critical value. We've seen critical value before in confidence intervals. A lot of the stuff that we've done in confidence intervals actually transfers over to hypothesis testing. So the critical value is based on the significance level and test type, which is then used to create a rejection region. You would have rejection regions here and here, or if it's a one-tailed test, you could have it to the left or to the right. Okay. And those are the rejection regions, the regions that are outside of what we would normally consider okay. Anybody need more time? Okay. Last real definitions, and then I have a statement. So test statistic is compared to the critical value in order to make a conclusion. If the test statistic is different enough and past the threshold set by the critical value, you can reject the null hypothesis. It is computed using the sample data. That one is important for you to remember. So it is computed using the sample data. Can I go to the next one? Okay. Okay, so the critical value is based on the significance level and test type, which is then used to create a rejection region. The test statistic is compared to the critical value in order to make a conclusion. If the test statistic falls in the rejection region, well, I'm going to say you can reject the null hypothesis. Now, what does this mean? So the critical value is based on the significance level. The significance level has this symbol, which is alpha. We've seen alpha before, okay? So let's say alpha is 0.05. Well, we know that if that is alpha, that it has a rejection region. If it is one-tailed, then that rejection region would be either to the left or to the right. And this value right here is the critical value. Okay, and that critical value is based off of the significance level. I'm going to go into more details with that in a second. If my test statistic is outside of this range, or it's in this rejection range, then I can reject the null hypothesis. If it is not, and if it would be over here, I would fail to reject the null hypothesis. And that's what they're stating by this. Now I'm going to show you a more detailed of this in a second, okay, with an example. I just want you to understand what they're saying with this problem. And if anybody came in late, we're writing down definitions. I would go back or look online at slides 2 through 4 and write down the exact wording of the definitions because it's going to help you with the practice that we're going to do with this section. So we're doing definitions. We have one more slide of definitions. Then I'm going to show you how the whole hypothesis testing works. And then we're going to do some examples of what we're going over today. And I'm going to show you how the terminology that we just wrote down applies to the hypothesis process.
Okay, thank you. Sorry, I was a little bit late.
Oh, no, it's okay. I understand. I just wanted to let you know what was going on so you're not like, what are we doing?
I appreciate it.
Ramadi,
Yes.
I'm not gonna be able to attend any more of this meeting because
Because you were in the car currently?
well, I'm not gonna get out for a while. I'm not gonna be able to attend any more of this.
Okay. Thank you for letting me know. I will be posting the PowerPoint's already up. The recording will be up after class, probably around 3 o'clock, and then you'll be able to watch it. Okay.
Okay, thank you.
Yes, no problem.
Here's to hoping I get to Hartford safely.
Yes, good driving to Connecticut, and then send love to your family when you get there. Okay. Good luck.
Thank you.
Okay. Okay. One more thing to write down. So the null hypothesis and the alternate hypothesis are complements to each other. And I don't know why this song sticks in my head. They go together like a horse and carriage. There's an old TV show. This is how old I am. Married with Children, which is like an old TV show. And the theme song to it had this. They go together like a horse and carriage. And I just have that in my head.
That show.
I
love
typed
all
it
the
into
old
the
shows
thing.
like that.
So that's what stuck in my head while I was reading this. So that's what happened in the slide.
I love it. I'll remember that now.
There you go. Okay. I'm going to show you a problem. Now, this problem has some stuff already figured out for you. I promise this week I'm going to teach you how to find all of this information, but I want to explain it to you and how hypothesis testing works for this. Okay. So from previous Halloweens, the weight of candy bags has been 4 pounds. Ellie wants to see if she can collect more this year. She goes and collects 5 pounds. She then tests to see if she collected more candy. Now, this down here is information that you will obtain in the hypothesis testing process. I'm going to teach you how to do those. The significance level is a set value that will be given to you. Okay? Significance level will be given in the problem. It might be 0.05, it might be 0.01, it might be 0.02, okay? Or 0.10. The significance level given in the problem. Now, the significance level alpha compared to p-value is one approach to solving this, okay? And the significance level is also kind of synonymous with the critical value. The significance level determines the critical value. They are set values from the problem that you can use to compare, okay? Critical value is compared to the test statistic. So I'm going to get to that in a second, okay? But if I have significance level and I want to compare it to the p-value, how I do that is I say p-value, if it's less than or equal to the alpha, which is the significance level, then we reject HO. HO is our null hypothesis. Okay. On the other hand, if our p-value is greater than or equal to our significance level, which is our alpha, then we fail to reject HO. You're not going to see this today. This is a precursor to stuff that we're going to be doing, okay? But I want you to see where we're going with all of this information, where the process is going. Now, significance level and critical value are the same. So if I have a significance level of 0.05 and it's a one-tailed test, my critical value is going to be 1.645. Okay, those are set values. They don't change. Remember how our Z alpha and our T alpha didn't change? We found them from the chart, or we found it from the invert T and the confidence intervals. It's the same thing. They're the same values. Okay. Now, we could take the critical value, okay, and compare to the test statistic. Now, the test statistic is found using the sample data. Okay, so we find it using our sample data and we get a critical value. Now, the critical value and test statistic are not as cut and dry as the p-value with how you determine them, but say my critical value in this example, okay, I'm going to go back up and see if I can make this larger. You can see more, okay. Remember my critical value is 1.645 and the test statistic that I gave you is 2.13, okay. That critical value is here at 1.645. And this being a one-tailed test, anything that is larger than that is outside of my acceptable region or my acceptable area. Remember when we did confidence intervals and you could be between 30 and 45, right? We were 95% confident that we were between those two values. Well, in this case, anything that's outside of this, where we expect our values to be, is considered different, or it's considered outside of the accepted. It is in the rejection region. So if we are to there, then I would say we reject HO when inside rejection region, or you word it like this, or when outside the accepted region. And I promise we're going to do all of these parts. I just want you to see where the vocabulary fits into the process. Now, the test statistic that we came up with was 2.13. Okay, and we can get that several different ways. I'm going to show you the formulas, one of them on Thursday. But we get that test statistic, and in this case, it is in my rejection region, right? So we would reject HO. And that actually follows the same as the p-value that is associated with it, because the test statistic gives us a p-value. These two relate to each other. The test statistic is determines the p-value. The p-value of 0.016, that is less than our significance level, and we rejected the null, and we reject the null in that one as well. You get the same conclusion either process. We're going to be doing the p-value, but I want you to see the critical value because either way can be done.
Just a quick question.
Yes.
So do you consider any data within the MAC area to be in the rejected region?
Not every time. So in this case, it happened to be, let me give you an example where it would not be. So if the test statistic is 1.93 and the p-value, hold on, let me find the p-value that associates with that so I have correct information. And the p-value of 0.0268, if our critical value and our significance level if our significance level is 0.01 and our critical value is 2.326, right? In this case, okay, we have 2.326 as the critical value. So anything above it would be in the rejection region, but our test statistic is actually here at 1.93. So it is inside of the acceptable region of what I would, so this case, we would fail to reject HO. Does that make sense? Is that what you asked?
Yeah, so you only reject when the test statistic is higher or above the critical value.
Right, and sometimes you can have it where you're going below that. Okay, in this example, it was more than. Sometimes it's going to be less than, and sometimes it's going to be two-tailed. So it could actually be above or below.
Okay.
So this is left tailed. This is two-tailed. And this is right-tailed. And we're going to go into those in more depth tomorrow, okay?
Okay.
The difference between, and then also if you looked at the p-value, 0.02 is greater than the significance level, so we fail to reject as well. So
Mm.
these should match up to make sure that they coincide with each other. Okay. And then there's more wording, which we're going to get into as well too. But that's how these vocabulary match with the hypothesis process. I'm going to go and switch back to the PowerPoint. You don't have to write this down. This is what we just talked about. This is the process. Okay. We will go through this. Today, we are covering identifying the claim and the vocabulary. Okay. Tomorrow, we're going to write the hypothesis statements and work about the type of test, the tail. And then Thursday, we're going to talk about the rejection region. And then, so Wednesday, the rejection region. And then Thursday, we're going to do full hypothesis testing examples. There are several different types. This part is chapter 9, when it's one set of information, and the 2 is chapter 10. You don't need to write that down either. We're going to go through each of them. Okay. Here is a visual of the rejection regions. Okay. Critical region, rejection region, acceptance region. So here's an example. We're going to work with this. An article about search engine optimization states that on average, the number of keywords that should be targeted when creating a website is 5 keywords. A website developer who is looking to increase traffic on their website believes the average number of keywords targeted for a website is different than the number stated by the article. After completing a study, the website developer found that the average number of keywords targeted in a website is, there's a double is. Oh, I want to get rid of it. Sorry. There it is. 5.6 keywords on average. Now, from this, we can write the null and the alternate hypothesis. The alternate hypothesis is your claim. It is what you're going to be testing or studying. Now, it's either going to be off of the population mean or off of the population proportion. Does this talk about mean or proportion?
I think mean.
Mean, because it says average, right?
Yeah.
So there's our keyword. Okay. So I see average. I'm going to automatically put mu and mu. Okay. Now, the top mu is equal. The bottom mu is going to have an inequality of some sort. Now, here's the trick with this. There are 2 numbers in this problem. There's 5 and 5.6, right? The 5.6, I'm going to insert words. The 5.6 comes from the sample, right? Because it said after completing a study, which is the sample, a website developer found that the average number of keys is 5.6 words. we do not use the sample, I'll fix this, for the hypothesis or claim. Okay, you cannot use that for your claim. It doesn't help you. You need to use what is known or what has been given previously as information. Oh, that's awful, sorry. Better. So in that case, we have to use what value for our hypothesis or for our claim?
Five.
5. Yes, exactly. So in this case, it's going to be equal to 5. Well, I am going to write that 5 for my alternate hypothesis too, and I need to come up with the inequality because the value in your null and in your alternate hypothesis should be the same value. They never change. So if it's 5 in my null, it's 5 in my alternate. If it's 332 in my null, it's 332 in my alternate. That doesn't change. Now, it said is different. If they use different, it is a two-tailed test, and the inequality for this is like this. It's not equal to. Okay, and by being not equal to, it's not specifying that it's less than or greater than. It could be in either one of those rejection regions. It could be above or below the rejection region. Okay, so these are two-tailed tests. And it could be in either one of these rejection regions. Now, how they would write the claim for this is test the claim that the keywords is different than 5. That would be the word claim for this. The HO and HA would be the mathematical symbol way to write it. Let's look at another one. An internet provider states that on average, the daily amount of time an adult spends on the internet is 4.5 hours. So I'm gonna highlight some stuff. We saw average 4.5. A sociologist studying the behaviors of internet consumers believes the average daily amount an adult spends on the internet is different than the amount stated by the internet provider. After completing a study, the sociologist found that the average daily amount of time an adult spends on the internet is 5.9 hours. We have our HO and we have our HA. Is it population mean or population proportion?
Population mean.
Mean, perfect. So we have mean for our null, mean for our alternate. It's going to be equal for our null. What is it equal to?
4.5.
4.5. Exactly, because that is the known value. Didn't come from the sample or the study. We have to use that. And we can write 4.5 down again for our alternate. What symbol are we going to have in between?
The equal sign with the slash.
Yeah,
I can't
the not
remember
equal
what it's
to.
called.
Yeah, it's just the not equal to. Exactly. And if I'm going to write this out, we are testing the claim that the average internet is different than 4.5 hours. I would like to think that it's different than that, but I don't know with school and work and everything like that. I assume that it's probably close to that, right? I'm going to pull up a problem so you could see. Okay. Here would be a problem you would see on Newton, just so you can see how the wording is. A recent published medical article states that the average percent of adults who receive a flu shot every year is 72. A doctor who studies various flu strains believes the average percent of flu shot is below the published amount. Interested in studying this further, the doctor records their patients who receive the flu shot yearly and finds the percent of those to be shot as 67% on average. We want the claim. Okay, the claim is the HA. It's what they're trying to test.
Mm.
Okay. So which one of these? Please type into the chat. Should it be A, B, C, or D that I'm selecting?
I'm gonna go B.
Oh, type it into the chat. Sorry.
Sorry, long weekend.
No, you're good. Yeah, you said you were going to be out and it was cold.
Okay.
So I'm going to highlight some things, okay? A doctor who studies various pollutants believes that the average percent is below the published amount, right? So below translates to less than, yes?
Yes.
Okay, so we need to work at ones that look at less than, which is this one and that one, yes? Now, the 67% came from where?
The
It came
average.
from the sample, right? So he's interested in studying this further. The doctor records their patients who received the flu shot year. So this is from the sample. We cannot use the information from the sample for our claim or our hypothesis. We have to use the other value, the 72. Okay, so when you're making your claim or making your hypothesis, right, you have to use it about the other thing. Okay, so the claim is based off of what is known originally, not what you're going to be using for your test statistic.
Mm.
Let me see if I can pull up another one. I don't know if it's going to go to the next problem being the same. Nope, hold on. Okay. No. Okay, here's another one. Try this. A social media platform states that a social media post from a marketing agency has 7 hashtags on average. A digital marketing specialist studying social media advertising believes the average number of hashtags used in a post from a marketing agency is different than the number stated by the social media platform.
Mhm.
After completing a study, the digital marketing specialist found that the average number of hashtags used by a marketing agency in a social media post is 7.9 hashtags. Now, I want my claim not to be based on the study or the sample. I need it to be based on what was known previously. So in the chat, are you choosing A, B, C, or D for your answer? Privately to me, please. One person has it correct in the chat.
Mhm.
Sorry, I'm going back up to respond to people. As I type, everything keeps going down. Okay. I think I responded to most people. So I'm gonna, now, people got that it had 7, right? Because that's the value that we're supposed to be using. Now, we need to include a direction for our claim. Okay, so it needs to be less than, greater than, different. Okay, so you have to select A for this one because it has the wording is different. The D, the average number of hashtags used in a social media post from a marketing agency is 7 hashtags. That would be your null. That is not the claim. I can't test that. That's just a statement. So I need to have something that I can test one way or the other. Okay. Let me see if I can, we're going to do some other problems and then hopefully we can write some out with those as well. Okay. Now here is where your vocabulary that you wrote at the beginning of this is going to come in handy. Null, so you either need to identify it as the null hypothesis, the p-value, the test statistic, or the significance level. Joanna, a machine learning engineer, is studying what programming languages are the most effective to help systems learn from data. Based on previous research, more than 50% of machine learning involves the use of Python, a programming language. She suspects this percent has increased in recent years. In the process of hypothesis testing, what set value, sorry, I'm trying to get it so I can underline it. What set value will allow Joanna to make a conclusion about whether her sample proportion is different enough than the claimed population proportion? Is this null hypothesis, A? Is it the p-value, B? Is it the test statistic, or is it the significance level, D? Look back at your wording, look back at the PowerPoint, and see if you find these specific words in any of your definitions.
Mm. So is it the significance level?
Yes. Okay, so if I look back up at my definitions, right, that we wrote down, and I look at significance level, a set value that allows us to make conclusions about whether a sample parameter is different enough than the claim population parameter. So that's why I said, please write them down exactly how I have them written down, because the wording makes a huge difference for this. Okay, then it will on your homework as well. So this would be significance level. Quickly, for this, my HO, okay, would be a P in this case because we have a percent, not a mean, okay? And we would convert that to a decimal to be equal to 0.50. Our alternate, or our claim, would be that the proportion is what? Less than, not equal to, or greater than?
Greater than?
Yeah, greater than, because it said more than 50%. So our claim for this the average proportion is greater than 0.50 or greater than 50%. Okay. Do another example with vocabulary. Critical value is A. Alternative hypothesis is B. P-value would be C, and significance level would be D. Heather, a sociology major, is interested in studying mass media topics. She is particularly interested in the percentage of mass media topics that relates to entertainment. Based on previous research, 72% of mass media topics relate to entertainment. She suspects this percent is different. During the process of hypothesis testing, she calculates a probability using the test statistic. What is the probability associated with the test statistic called? Please type into the chat privately to me your answer. Is it A, critical value, B, alternative hypothesis, C, p-value, or D, significance level? Anybody else want to try in the chat before I talk about it? Okay, so I'm gonna go back up. And look at p-value. Look at the little definition underneath of it. It says the probability associated with the test statistic. Does everybody see that right here?
Yeah. Oh, the p-value.
Okay. So this question is, what is the probability associated with the test statistic called? So the answer for this would be the p-value. Okay, because remember, you get the test statistic, which could be t or it could be z, and they are some value, right? They could be anything, right? Normally between -4 and 4. And then from there, they give you a p-value, which is a probability. It's the probability that it is going to occur or not occur. Okay. And if your probability is high, then it's going to happen. If it's low, then it's not going to happen. And normally when it's low, you can reject. And if it's high, you fail to reject. So those are the only examples I have today. The reason I only have 2 examples is because I want you to spend the next 15 minutes of class on 9.1.1 doing the homework. Because I can talk to you until I'm blue in the face, but until you actually read through the problems and eating food, Abby says, until you actually look through the problems and see the wording of how it is, it's not going to make sense. So you don't have to stay on screen. This is an honored code system. Take the next 15 minutes. My in-class people were done with their homework in 6 minutes. Okay, so if you take the next 15 minutes, you could be done with the homework for tonight. So 9.1.1 is the homework that you're supposed to do. We will have class tomorrow, and tomorrow we will go over the null and alternate hypothesis and the left, right, or two-tailed test and how to determine those. Okay. And then we only have 13 more classes, and then you're done. Okay. So you can do this. I know it's the end of the semester. Okay. Go practice. I'll stop recording.